Today's session is Advanced Color Management for Digital Print Systems. It is my pleasure to introduce our speakers for today, Lou Prestia, Senior Product Line Manager, and Heather Blakely, Product Marketing Specialist. So with that, Lou, please take it away.
Thank you, Yael. Hello, everyone, and thank you for joining our session. In today's session, we're going to cover the following topics. We're going to talk briefly about color management basics. We'll then look into some detail of some advanced color management topics, including profile selection, specifically the use of embedded profiles, and the PDFX output intent, which is one example of an embedded profile. We'll talk about settings for rendering intent. We will talk about the controls on the DFE for black point compensation. And then we'll study, toward the end of our session, some challenges that we have with color management for digital print systems, specifically challenges with printing black and white jobs or keeping black and white clicks on jobs that are only using black. And we'll talk about some common sources of color management failure. Finally, we'll close today's session by showing you recommended DFE settings, again using the Fiery controller for our example. Today is an advanced session, so before I begin, I want to remind you that there's some background out there. You may have already seen some or all of these materials that we have, which includes earlier webinars that we've done on basic color management. I think you should be able to follow the session today. I'm going to go slowly, but there's some advanced topics. So if you find that there's some background that you're missing, you might want to go back and use some of these other resources that we're showing you on this slide, including our earlier basic color management webinars that we've done previously. So let's talk for a minute about color management basics. And I know that many of you in the session today already understand this, but I just want to give a quick reintroduction to remind us all and help anyone out that may not remember this basic sort of function. So the way ICC color management works is that I need an ICC profile to represent an input space. So, for example, an RGB input in a file that I'm going to print, might be a PostScript file or a PDF file, needs some kind of definition for color management. In order to complete color management, I always need at least two profiles. The first input profile to convert the colors into what we call the profile connection space, which is this device-independent space that we measure with a spectrophotometer. And then I need a second profile to convert out of the profile connection space and into this color space of the printing device. Now this is typically a CMYK output profile for a print system. I might also have CMYK inputs, I probably do in my PostScript and PDF files, so I'll need to specify a profile for input of CMYK as well. I want to introduce today a color flowchart that we're going to use to look at how color is processed on the Fiery. And before we get to showing you that whole flowchart, I want to give you a quick introduction to it. So if we look at the color settings on the Fiery DFE, we can go to the expert settings to see the controls that are represented on the color flowchart. The expert settings have three tabs. The first one is for color input. You can see this is where I set those source profiles that I talked about in the last slide, and we'll talk in more detail about these controls. When I go to the color flowchart, you'll see that this input section of the user interface is represented in the upper left-hand corner. There's a second tab within the expert settings for output, and this output section is shown below the input section. Finally, there's a third section for gray and black processing, and on our color flowchart we represent that at the bottom of the left side of the flowchart. Now we need to explain how different color spaces are processed in our input page description files based on these settings. So as we saw in the last slide, or a few slides ago, we'll have CMYK inputs, we'll have RGB inputs, and we'll have spot colors in these files. So we'll use the color flowchart, which looks like this, to study how each of these different color spaces in a page file are processed based on the color settings on the Fiery. Before we proceed, I want to tell you that this looks like a complicated diagram, and I don't want you to be too concerned at this moment about all the details in it. We're going to go through this piece by piece, and I think it will be clear to you as we go. Ultimately, we will share with you, after the presentation, a separate video where we go through the flowchart step by step and show all the settings on the Fiery and their impact on the color spaces in your page description files. So let's move on to our first topic, which is the topic of embedded profiles.
Hey, before we do that, I think we'll open up a quick poll. We want to get your feedback on 3 quick questions. Should take you a minute or 2. Let us know how often you calibrate. Do you use custom profiles for different paper types? And finally, what kind of lights do you use for viewing proofs? And as you do that, Lou will continue with the presentation, and we will be referring back to the results of these polls within our presentation later on.
Okay.
Move forward.
Thank you. When we talk about embedded profiles and page description files, the first thing we need to understand is that most of the modern applications that we use to do design, such as the Adobe Creative Suite, have the concept of a working space. The idea of a working space is a standard RGB or CMYK space that we create all our design documents in, and these RGB and CMYK working spaces are defined by ICC profiles. When we save from these applications, the best practice, and typically the default setting, is to embed the profile for the working space that we've been working in. Let's look first at Adobe Photoshop. In Photoshop, we define a working space for CMYK and a working space for RGB. Photoshop is relatively lenient in that it will let me have many documents open with many different color spaces, but it prefers, and when I create a new document, it will always create it in my working space. So this is an example of us having different windows open with different color spaces in Photoshop. When I configure the working space in Photoshop, I go to the color settings and I pick 2 profiles for my working RGB and CMYK. The example I'm showing here, we're picking the Adobe RGB source profile for our RGB, and we're picking the swapped profile for our CMYK working space. Photoshop and the other applications in the Creative Suite also have policies about when profiles mismatch. So this has to do with when I'm working in a specified working space, such as Adobe RGB that we show here, and I go to open a document or paste from a document that's in a different color space. In this case, and you've probably seen this many times, you'll get a warning from Photoshop. It will say there's an embedded profile mismatch. In this example, I'm opening another document that actually has a monitor profile assigned to it, which is actually very bad practice. And Photoshop says, I'm working in RGB. What should we do? Typically, the best choice is to convert it to our working space, but in some cases we use the embedded profile so we can see the appearance of the file before we make that conversion. As I said a few minutes ago, when I save a file from Photoshop, I will be encouraged, in that the default setting is enabled, to embed the profile. That means now whenever we open up one of my RGB documents from this copy of Photoshop, I'll know that I worked in Adobe RGB. That profile will be embedded in the image file that I'm saving from Photoshop. Before we move on from Photoshop, I'll show you one other quick trick here, which is that in the lower left window of your Photoshop window, by default, you're seeing the document size. If you click on that document size in the lower left corner, you can choose many different things that Photoshop will display. I recommend you set this to show the document profile. This way, if I have one window open that's in my sRGB space and one that's in Adobe or in some monitor space, I can keep track of what color space the different windows are in, and when I go to copy and paste from one to the other, I will be probably not surprised to see that mismatch dialog and have to make some decisions. When we look to Adobe Illustrator, Illustrator also uses working spaces. Illustrator offers a unique choice when we have a profile mismatch with CMYK. So in Photoshop, if I'm working in swap CMYK and I open a file that's perhaps in ISO coded CMYK, I'll get a mismatch warning and Photoshop will say, do you want to convert this into swap or do you want to leave it in ISO space? Illustrator gives me another choice. It gives me the choice to preserve numbers. Preserve numbers means keep the CMYK values that were in the source file without respect to the profiles. So it basically disables color management for CMYK. It ignores the embedded profile. When we open the file and preserve the numbers, if we do a color managed workflow to the data later, we're going to probably have some unexpected results. So that looks like this. In the configuration for Illustrator color settings, again, I pick my working spaces as I'm showing at the top here. And then for the color management policies in CMYK, I can choose to preserve the numbers and ignore linked profiles. This is a fairly common case with users today, but a good recommendation is to change this to preserve embedded profiles. Now if I open an ISO document from some shop, maybe outside the US, I'll keep the profile that defines the way they expected that color to look. InDesign is the most has the greatest latitude for color management profiles of all the applications. Because this is our page geometry application, InDesign lets me have a different profile assigned to each and every object on the page. I can use the command in InDesign called image color settings to see the profile assigned to each object on the page. So every graphic and image and other kind of object on the page can actually have its own profile. How do we use these working spaces on the digital front end? Well, the first thing is, if we create the documents ourselves and we know the working spaces that we've probably synchronized all our Adobe Creative Suite applications on, we can choose these settings on the DFE. So I'm showing you the basic color settings on the Fiery DFE here, and I'm basically just picking the input profiles to match whatever my working spaces are in my copy of Photoshop or Illustrator, whatever design application I may be using. If I have embedded profiles in my documents, there's a couple different ways to find out that I have these. The first one is I'll know from the Adobe applications, and then when I'm saving, I'm saying embed profiles. The other tool I can use to examine a PDF file is Enfocus Pitstop. If I use the Pitstop Inspector feature and I select an object in a PDF file, such as this color circle that I'm showing here, we can see that that color wheel there is defined as RGB. It's using an ICC-based space in the PDF language, and it's defined by the Adobe RGB profile. So this is an example of an embedded profile in the PDF file. On the Fiery controller, if I want to use the embedded profiles, I need to go to the Advanced Color Input settings, and I need to check these boxes for Use Embedded Profile if present. You'll notice in my example that I'm showing you Use Embedded Profile for RGB only. The reason we don't always recommend setting embedded profile use for CMYK is first and foremost that a lot of CMYK isn't properly color managed. So one example of that is the Preserve Numbers option that is used by many users in Illustrator. Another example is the fact that traditional shops often don't color manage CMYK at all. They want to keep everything in the same legacy CMYK space they've been working in. So if one of their applications embeds a profile that doesn't really represent the way they expected the CMYK to look, we can get an unexpected appearance on the output of the digital print system. The other reason we'll talk a little bit later about is that when I try to use some of the advanced features on the Fiery DFE for preserving black and keeping black and white click charges for grayscale pages, using embedded profiles for CMYK can cause me some additional challenges. So if we turn to our color flowchart, now that we have been introduced to it a little bit, let's look at what these settings do. If I have page description files that have basically 4 kinds of spaces in them that I'm showing you at the top of the diagram, I could have 4 possible permutations of color in that file besides spot color. I might have some CMYK page objects without an embedded profile, some CMYK with embedded profiles. I might also have RGB page objects, some of which may have or may not have an embedded profile that I show you in columns 3 and 4 of the color flowchart diagram. So if I enable Use Embedded Profile when present in the user interface, and I'm turning it on here both for CMYK and RGB, now you see that the source profile for the CMYK and RGB that had embedded definitions changes. We used the definition that was embedded in the file when we created the PDF, or when we created the PostScript file in a device-independent fashion. The other thing that it's important to understand is that when I use embedded profile for CMYK, the CMYK is now treated as LAB. Notice at the bottom of this user interface, we show settings at the top for CMYK grayscale, and the bottom for RGB and LAB. LAB, a device-independent color space, is the way we represent to the user colors that are being managed as device-independent. And one great example of that is if I have a CMYK page object, it has an embedded profile. If I choose to honor that embedded profile by setting Use Embedded Profile when present for CMYK, now the data is no longer treated as a CMYK input. It's treated as a device-independent, or what we could call an LAB input, and that means that it's going to pick up the rendering intent from the bottom section. So it's going to change its rendering intent in this example from relative colorimetric, which is what we typically use for CMYK on the Fiery by default, to photographic. We'll talk a little bit more about rendering intents in a few minutes. Before we get to that, I want to talk about one special example of embedded profiles. The PDFX output intent is a tag in a PDFX file which is defined by the Ghent working group. PDFX files have existed for some time as a way of standardizing PDF for print production. So there's various versions of this out there, PDFX1A, PDFX3, the latest is PDFX4. All of these PDFX files can include this tag we call the output intent. The output intent is actually an embedded ICC profile that is intended to standardize the appearance of the PDF file everywhere I use it. Whether I view it on the screen or print it on various print systems, the idea is that the appearance of the output should match the profile that's contained in the output intent. Let's look at this in the ICC workflow. So if I have the normal color management settings that I've described, I have input profiles defined for my RGB and CMYK, could be embedded or default definitions from the DFE. I'm going to convert those colors into device-independent color space, the profile connection space. If I'm using the PDFX output intent, before I convert these colors for the output, I'm going to convert them into that PDFX space. I'm going to make them look like the profile that's in the PDFX output intent. So a common example that people put in the PDFX output intent is a swap profile. They say, I want this document to look like swap no matter where in the world it goes, no matter where it is printed or viewed. Now we take the colors that are defined by that PDFX output intent through the profile connection space again and convert them through the output profiles. This might be a monitor ICC profile so that the display on the screen looks like the swap profile, or it might be our usual CMYK output profile for the digital print system, and again, this will make the PDF file look like swap on the output device rather than look like the best representation of the input color spaces, which in fact might have more gamut than swap, and particularly the RGB input. So in order to use PDFX output intent on the Fiery DFE, I really need to do two things. First, I enable the option in the Advanced Color Input section to use the PDFX output intent. This causes the Fiery, if we go to our color workflow diagram, to use the ICC that is in the PDFX output intent as the source profile for CMYK. So now my CMYK, rather than looking like ISO coded FOGR 39 that I've defined up there as the default CMYK, it will instead look like whatever the profile is in that PDFX output intent tag, perhaps swap in the example that I've been describing. The other setting I need to use if I want to be fully compliant with PDFX output intent is I need to set this control that I'm showing at the bottom, the separate RGB to LAB, separate RGB to CMYK source. This causes the RGB input spaces to be converted to the CMYK source before they're printed. So both my inputs in RGB, which are first defined as sRGB and Adobe RGB in this example, next get converted into the output intent profile, perhaps swap as I've been saying in the example, before they get converted into the output profile space. This gives us consistent appearance for both the CMYK and the RGB page objects in the PDF file. So one common question we get is, why don't we just turn this on all the time? If I might get some PDFX files, and they might, and incidentally they don't always have the output intent tag populated, but they might, why don't I just always use these settings so that I can always get these files right? And the answer is that if we always use the PDFX output intent, we can get overcompression of our colors. Imagine if I have a bright, beautiful picture in Adobe RGB space, perhaps the output profile on your digital print system is for also a very broad gamut, a nice heavy coated sheet. If I take that Adobe RGB and I compress it down into the swap space, that might be what's in my output intent, I'm not going to get as pleasing an appearance on the output on that nice coated media that in fact has more gamut than the swap space. So in general, the recommendation for PDFX workflows is that you probably should create a virtual printer or more likely a hot folder where you enable not just the two settings I've shown, but all the settings that are needed on the Fiery to properly process PDFX files, and you specifically put customer documents in there that you know are supposed to comply with the PDFX standards. Speaking of overcompression of colors, let's talk about rendering intent and gamut compression. So the first piece of this to understand is that gamut compression happens whenever I color manage colors from a large space, which might be my RGB source of Adobe RGB or sRGB, into a smaller space, which is typically going to be the CMYK of my output device. So if you look at the diagram here, we're showing you in 2 dimensions a plot of the gamut of the RGB space and the much smaller CMYK space. The question is, what about all the colors that are in the RGB source space that aren't initially fitting in the CMYK space? What happens to these colors when I do color management is that they get compressed. So I have gamut compression. When we look at the setting for rendering intent on the DFE, the rendering intent is essentially our preference for gamut compression. So you can think of it in this way. We're going to have to smash some of your colors. The rendering intent is your preference for how you would like the colors to be smashed in a particular instance or for a particular job. And there's 4 general settings for rendering intent. These are photographic, presentation, relative, and absolute colorimetric. Let's look at an example of how each of these rendering intents works. So the first rendering intent, which we call photographic on the Fiery, is also known as the perceptual rendering intent. Perceptual is the name that's used in standard ICC nomenclature and in some of the applications including the Adobe Creative Suite. For an example, if I look at the RGB source space, which is this much bigger space than the destination output space, and I give an example of 2 colors in this space, so I have color number 1, which is outside the gamut of my print system, and color 2, which is already in gamut of the print system. If I set the photographic rendering intent on the Fiery for my RGB sources, then when I color manage the RGB and convert it into the CMYK space, the gamut compression looks like this. I move color number 1 which I have to get it into the destination gamut so I can print it. And I also move color number 2 by relatively the same amount as I moved color number 1. The reason for preserving the relationship between these colors in the photographic rendering intent is to give a natural appearance on the print. So an example of this is if you have a picture of someone's face next to a bright red fire truck. If we compress the red of the fire truck, so now it looks more dull on the output system, and we don't also compress the warmness or the redness that is in someone's face, then the person's going to look very red compared to the fire truck without the use of the photographic rendering intent. The second rendering intent we commonly use is called relative colorimetric. Relative colorimetric, giving the same two colors in the source space. When I convert these with the relative colorimetric rendering intent, you'll see that color number 1 is clipped into the destination gamut, since it has to be, we need to print it. But color number 2 is left right where it started, because it was already in the destination gamut. An example of why I would use the relative colorimetric intent is for graphics and logos. Imagine if your business logo has 3 colors in it, one of which is out of gamut for my print system. You wouldn't want me to convert or compress all the colors of your logo. I might have to sacrifice or compromise one. You'd probably want the other colors in the logo, if they were in the output gamut, to reproduce as precisely as possible. So the classic application of relative colorimetric is for logos and graphics. The reality is, if I compare relative colorimetric to photographic, I'm going to typically see very little difference. Photographic will give me better shadow detail if I have very broad gamut originals with a lot of shadow detail. It will also give me a more natural color appearance if I have an extremely broad gamut source space, so something like wide gamut RGB, and if I have a picture that has colors in all the corners of that gamut. So maybe if we're taking pictures of people in sportswear, skiing or surfing, or for some reason we're taking pictures of rainbows in a large source space, then the photographic rendering intent will give me a better result. In many cases, if I don't have broad gamut sources, or I'm not printing pictures with a tremendous amount of color gamut or shadow detail, the relative colorimetric can also be used for RGB inputs. You'll notice that relative colorimetric is in fact the default setting in Photoshop when we convert colors. The third rendering intent is what we call the presentation rendering intent on the Fiery DFE. And another name for presentation is saturation. You'll see why it's called saturation in a moment. If I have the same situation with color 1 and color 2 in the source gamut, when I compress them with the presentation rendering intent, I first basically perform relative colorimetric gamut compression. I clip color 1 into the destination gamut while preserving the exact appearance of color 2. But because I'm in the presentation intent, I move the colors one more time. In this case, as I move them toward the outside of the gamut, or in some cases the corner of the gamut, where I have more saturated, more pure colors. This is the right treatment for business graphics, since if I have a PowerPoint slide with a bright red in it, I don't really want it to have 7% cyan dot in there to make it colorimetrically accurate, right? When I show that slide with 7% cyan in there, it might look very funny on the presentation. So the presentation rendering intent is best for business graphics. Yes, we have some customers that like to use this for RGB inputs. It gives a very saturated output for the RGB sources, but they tend to look very unnatural if we make them oversaturated in this way. The last rendering intent is called absolute colorimetric. Absolute colorimetric does the same compression as relative colorimetric. So color number 1 is clipped to the destination, the print gamut. Color number 2 is preserved exactly in the same place it started. But when I do absolute colorimetric rendering, I also scale the white point from the source profile to that of the destination profile. That means that I simulate the white point of the source on the destination. And for RGB to CMYK, this isn't a particularly useful example. But if I'm converting from CMYK, let's say the swap gamut, to the CMYK gamut of my output device, and I use absolute colorimetric, I will actually simulate the paper white of that source profile. Why would I want to do that? I would only want to do that if I were in a proofing application, where I want to show you on my high-quality output from my digital print system the way the print or the image is going to look on a swap press, which has a relatively yellow white point, since that profile for swap is made on a relatively yellow sheet compared to some of our modern high-quality production stocks like a number 1 sheet we might use on the print system. So I explain relative colorimetric just so you have a complete understanding of rendering intents. I think for almost all the real-world applications you're dealing with, we're going to suggest you use photographic for RGB sources and relative colorimetric for CMYK sources. I won't read you through all the detail on this particular slide, but we'll leave it in the presentation and the recording so you can go back and refer to it for more detail later. So how do I set the rendering intent on the Fiery DFE? I have controls for the rendering intent of RGB. Remember, this will also impact the color spaces that have an embedded profile if I choose to respect it, since they'll be treated as LAB. And I set it here to the photographic rendering intent. For CMYK rendering intent on the Fiery DFE, we don't show the rendering intent. The Fiery always uses the relative colorimetric rendering intent for CMYK sources. This is the best choice for CMYK. Remember, the CMYK source gamut is rarely bigger than the output gamut, or it's maybe a little bigger, but not larger enough to do the kind of overcompression that I might get from something like the photographic rendering intent. There are 3 choices of processing method on the Fiery DFE, including full source GCR, full output GCR, and pure primaries. Just to give you a little background here, source GCR is a setting that was used on legacy Fiery systems to try to preserve black inputs to print as black only on output. We'll talk a little later in the presentation about how we do that on modern Fieries. Full output GCR says use the relative colorimetric rendering intent and use the black generation that's defined in my output profile, which is absolutely the black generation you need for your digital print system if you want to be colorimetrically accurate, if you're trying to match any kind of standard like Crackle or ISO or swap. Only full output GCR is going to give you that colorimetric precision. Pure primaries is another legacy setting that some users may choose if they want more saturated CMYK output. This tries to keep the colors pure, so it's a little bit like it's a little bit like the presentation rendering intent that we showed you a few minutes ago, but it actually pushes the colors even more towards the corners of the gamut where they're pure and not just more saturated. Again, pretty uncommon to use pure primaries today unless you're trying to make very bright and clean CMYK that probably isn't going to look very natural and certainly is not going to be very colorimetrically precise. Remember, when we have embedded profiles in use, the rendering intent will be defined by the RGB LAB tab. So in this case, all of those input spaces that have embedded profiles, I'm going to use the photographic rendering intent for. Another setting we have when we look at advanced color management, and something we see from the Adobe Creative Suite, or at least from Photoshop, is a control for what we call black point compensation. Black point compensation maps the black point of the source profile to the black point of the destination profile. There's really only a few cases when this makes a difference, and this is typically when we have a light shadow point in the source space that we want to maintain in the destination space. The only example of when I'd want to do this probably is if I was proofing. So normally we leave black point compensation always enabled. This gives us not only the best detail in the shadow areas, but also gives us the best contrast. So if we look at a kind of unusual example here, the image on the left has a source ICC space defining it as newsprint. So this is a very washed out appearance such as we might see in the newspaper. If I print this with black point compensation enabled on the Fiery DFE, I'm going to get a fantastic reproduction as you see on the right. I'm going to map that washed out shadow point from the newsprint profile into the very dark, dense, detailed shadow point that I have on the output profile I've created for my Fiery. Only if I were proofing would I want to disable black point compensation. This will give me the same washed out appearance on the output that I had on the input. And again, for proofing, this might be useful. Before I go on to this next section, I just want to give you one other detail about the black point compensation, which is that we always want black point compensation for RGB to CMYK conversions, and for that reason you'll see on the Fiery DFE we don't even give a control for black point compensation. For RGB conversions it is always enabled, since there's no case where we'd want to proof RGB or we wouldn't want the best appearance and best shadow detail from our RGB sources. So let's look at some challenges with color management. The first one is problems printing with black, and we kind of talk about this in terms of this feature we call print gray using black only. Sometimes you'll hear someone say pagubo. They mean print gray using black only. And this goes back to a classic challenge for color management systems with black input spaces. So let's imagine you get a job from a customer that is entirely grayscale, or maybe almost all the pages are grayscale. There's a couple of color pages in there. You go to print it on the Fiery, and you expect that you're going to use black and white clicks to print the black and white pages. Here's what happens. Some page objects on those grayscale pages are probably defined, perhaps accidentally by the designer, using the RGB color space. They appear gray because the RGB channels are all equal. So an example here is a mid-tone RGB, looks like a gray to the eye, but it's actually composed in the design file of red, green, and blue, each at the 128 level. If I color manage RGB of 128, 128, 128 through a source profile like sRGB or Adobe RGB, I look up through that profile the appearance values in the profile connection space for that mid-tone RGB. Maybe it's something like 62 in the L-star channel, 0 in A, and 0 in B, since we have a perfectly neutral color. When I take the lab combination 6200 through the output profile thinks that I want to print a mid-tone gray. And one example of a formula or a recipe that might come from the output profile for that mid-tone gray is something like 40% cyan, 30% magenta, 30% yellow, and 20% black. A perfectly neutral mid-tone gray in the CMYK output space. What's the problem? The problem is this is going to cost you a color click on your print system. So you thought you had a grayscale input, but when we color manage it turns into color. And this is not specific to the Fiery. This happens on all color management systems and all DFEs that process apparent grayscale inputs in the world. They have the tendency, based on the way color management works by default, to convert them into colors. So another common example is the CMYK input. Maybe all the pages in grayscale were accidentally made as CMYK. Using black as the only value on the page, so one example is the black channel is at 50%. There's no cyan, magenta, or yellow in any of these page objects. But when I color manage that 000 50% K into profile connection space, I again get a neutral LAB value. When I convert that through the output profile with default color management, I again get a 4-color gray output. Again, it results in a color click that I didn't expect. So to solve these settings on the DFE, we give controls under what we call gray and black processing in the advanced color management settings, and there's a simpler form of these available on the basic color management tab as well. If I turn on gray and black processing, for RGB and CMYK inputs, I can control this. I can force these inputs to print as black only, meaning you pay for a black and white click rather than a color click on that page. For RGB, our recommendation is to set gray and black processing to text graphics. The reason is that I might have images in RGB space with red and green and blue equal, and I don't want to convert those to black only. I'd get dropouts in the images that would look unnatural. For CMYK, it's safe to set the gray and black processing for all page objects, text and vector graphics and images. Any case of a CMYK page object that has black only in it, I want to print it as black only on the output. So these gray and black processing settings allow me to configure the Fiery to print what appear to be grayscale inputs as black only output that you pay the black and white click charge for. We have some additional controls in the advanced color section of gray and black for pure black. Pure black is a solid black. So if it's defined in RGB, it would be 0, 0, 0 in the RGB channels. If it's defined in CMYK, it would be 0%, cyan, magenta, and yellow, and 100% black. To properly render solid blacks, I can use the black text and graphics setting and set it to pure black on. Pure black on will result in all the page objects that are solid black being printed with 100% black only on the output. If I'm using pure black, another thing I can do is enable overprint. We'll talk about that here. I can enable overprint for different kinds of page objects, but really if I'm using pure black on the Fiery, I probably want to set this to text only, since it's really only text that it's safe to overprint. The other choices for pure black is I could configure it to use rich black. Rich black will cause all the solid blacks to be printed as 100% black and 40% cyan. So you're going to get a color click charge at this point, but the reason we sometimes choose to use a rich black is to make pages that have large areas of black coverage look more dense, more black and less gray, and in some cases less mottled. We can get a smoother appearance if we use a support screen of cyan. The other choice is you could set pure black processing to normal. In this case, we'll color manage those solid blacks. You will get a color click, and you'll probably get some combination of CMYK on the output rather than solid 100% black. Let's look at some challenges or some points where color management can fail or appear to fail. So you've done all your homework. You've attended all of our World of Fiery webinars. You've read all the books and publications and subscribed to all the mailing lists. Color management in your shop should be configured as well as it is in any other print shop in the world. For some reason, you're still having challenges matching color, or you're having to do reprints or rework because customers are dissatisfied with color either on the first run of the job or commonly on a reprint of a job that they expect is going to match the original run. The first problem is related to calibration. Calibration is essential on the DFE. If I don't calibrate the device, I have a situation where my colors aren't landing in a consistent place from day to day. We see this in the lower left corner of the slide. If I calibrate the Fiery using a spectrophotometer, typically the ES1000 or ES2000, I now get into a calibrated space where my colors are landing close to the same place. So they are very consistent. And if I calibrate the Fiery on a daily basis or every shift, as many shops do, I'm going to have consistent output over time when I go back to do reprints. Calibration by itself is not enough. I also need an ICC profile so that the colors are colorimetrically accurate and matching the source that I'm trying to match, such as Grackle or Swap. If I create the ICC profile without calibration, you'll see that my colors get closer to the bullseye in the lower right corner of the slide, but they're not in the middle. the best place that I want to be is with a custom ICC profile for my output device and a calibrated state of the DFE so that I get consistent and accurate colors. So we did a poll earlier, and one interesting thing that I wanted to look at is how many of the attendees of today's session calibrate the digital print system and how frequently. We see that about half of the attendees calibrate the Fiery on a daily or weekly basis. About a quarter of you calibrate it daily, which is really the best practice, but the fact that another 25% of the group calibrates on a weekly basis is also excellent. There are a few, probably on the order of 10% of the group that's attending today, that have never calibrated the Fiery. Say they calibrate once a year, which I'm not sure what that means or what that would do. So this is typical response that we see. Chances are that at least 25% of you are getting tremendous consistency on your prints, and probably the other 25% that calibrate on a weekly basis are certainly being more successful with their output than customers that calibrate less frequently than that. If we look to some industry statistics, we find from InfoTrends survey in 2015 that they find 25% of the digital press owners they surveyed never calibrate or calibrate on the annual basis. So that's different than the answer we got from this group. Only about 10% of you are in that situation, but I'm imagining that because you're watching the Advanced Color Management webinar, you're probably already starting with some of the best practices here. The other thing to understand before we go on from calibration is about the profiling. We asked the second poll question about whether you use custom profile for individual paper types. Almost 50% of the group says they are using custom profiles for individual paper types. This is spectacular information. That means half of you are not just consistent, but also accurate. You're probably colorimetrically matching a standard like SWAP or Grackle or ISO coded in the rest of the world. Remember, for the percentage of you that are not yet using custom profiles for each paper type and each print setting, you're going to get a lot better color appearance and a lot more reproducible appearance over time for reprints if you go and make profiles for the individual paper types. If you have a Fiery DFE, the tool you can use for this is Color Profiler Suite. The Color Profiler Suite Express module lets me make a custom calibration and a profile for a paper type in 5 steps. At the end of that, it links these together into a preset. I can use that preset whenever I print on that paper to get the right calibration and profiling. The next area of failure for color management is related to the settings on the digital front end, and there's a few different kinds of settings we can look at here on the Fiery. The first one is the imaging settings. So if I go to a job in Command Workstation and I go to the Image tab, you can see the image settings for your digital print system, and these are going to look different on every different kind of Fiery you might have based on the manufacturer of your press, the capabilities that we have on that press. But the key things to focus on in the image settings is the resolution and the halftone screen that you're printing with. If you change the resolution or change the halftone screen, you're probably going to get different tonality. This means that if you calibrate with one resolution and halftone, or profile with one resolution and halftone, and then change this later for different jobs, that calibration and profile are not going to work in the way they intended. So again, one of the benefits of using Color Profiler Suite and getting this preset created for a custom profile and calibration set is that it also locks in these imaging settings into that preset so that you can't make a mistake. The second challenge is to configure the source profiles. We talked about that in some detail in today's session. Probably we want to match these to the working spaces of our customers. The third area of challenge is the output profile selection. So if you look on the Fiery DFE, depending on the configuration, you may be selecting the output profile manually or automatically. If I specifically pick in Job Profiles an output profile, like the Fiery demo profile that we showed you earlier on the flowchart. Then you're going to use that profile just for this job. This is absolutely the worst way to configure your DFE. If you're manually picking a profile for each job each time you print, there's a high probability that you or one operator in the shop is going to pick the wrong profile one day, or that you're going to pick different output profiles on the first shift compared with on the second shift. So the best practice on the Fiery is to use the setting called Use Media Defined Profile when you go to the job properties or the Fiery default color configuration. If I use Media Defined Profiles, then I need a little help understanding how does the profile get selected. First, if the Use Media Defined Profile setting is selected, we check to see if the Fiery paper catalog is being used by the job. The paper catalog is specified here on the Media tab of the job properties. If I use a paper catalog entry, we'll try to pick the profile from the paper catalog. So the next question is there a profile defined in the paper catalog? A paper catalog entry looks like this, and in this example you can see that I've selected the profile plane number 1 for the front and back of my sheet. So in this example, the output profile will be selected based on the paper catalog entry and the profiles that are assigned in that entry here. Some Fieries don't offer a paper catalog, or for whatever reason you might not be using the paper catalog. If paper catalog is not used in the job, then we look to see if there's a profile assigned to the paper or media type. That's configured here in the Device Center of Command workstation under the Output Profiles. You can see in this example that the plain media type is assigned to use the Fiery Demo Plain profile. So if in Job Properties, when I configure to print the job on the Media tab, I choose the plain paper type, since I'm not using a paper catalog entry, in this case, the profile will be selected based on the media assignment. So we'll get the output profile assigned to the paper type. Notice that if I use the paper catalog and I haven't done any associations in the paper catalog, this is also how the profile selection is made. Okay? Before we go on, you're seeing the two very best practices for automated profile selection. I want to also remind you that when we create profiles for a Fiery with Color Profiler Suite, if you use the paper catalog in the course of creating the profile, we actually populate that entry for you. We put the custom profile that you've made in place for the front and back profiles on the paper catalog entry. Other situations. If there is not a profile assigned to the paper type in the Device Center, then we're going to use the default color settings profile for the Fiery, which is the one that's set in the Device Center. We're getting into an area of uncertainty here because that's probably not the right profile for the different paper types you're printing on. Lastly, if I choose to specifically pick the output profile for the job, I'm going to get the profile I selected. Seems like a very easy choice, but again, this one has high risk because of the fact that different people pick different profiles at different times, and also because of the fact that I might want to go back and do a reprint of this job in a week or a month or 6 months, and it's very unlikely that I'm going to remember what output profile I selected for the job. The last problem we encounter with color management, or probably the most common failure I see once you have all your best practices down, is problems with lighting and what we call metamerism. Metamerism has to do with colors that look the same in one light source and not another. This gets into the area of how we measure our colors, whether we use the M0, M1, or M2 measurement mode of our spectrophotometer, which we've talked about in some other sessions. In order to understand metamerism and the way two colors could look the same in one source but not another, it's interesting for us to examine some spectral data. So these graphs represent what we call spectral power distributions. We've talked about in earlier webinars. The spectral power distribution shows me how much energy a color has at each wavelength. This is the raw measurement data that we get from a spectrophotometer before we convert the spectra into LAB or XYZ or some other device-independent color space for purposes of color management and making profiles, we have this raw information that shows me an invariant description of the color. Shows me how much energy each of these colors has at each different wavelengths. So if I look at the spectral power distribution of the two colors shown in red and blue on the slide, you can see that spectrally they're very different colors. They're not what we would call an invariant match, where the plots of the spectral power distribution would be identical. Now let's consider an example where I put these two samples in a light booth. And in my light booth, the peaks of my red and green and blue lamps, or energy, in the white lights in the light booth happen to be at these positions. The peaks of these lamps are pointing at cases where the spectral power distributions intersect. In this lighting, these colors will appear to match because they have exactly the same amount of energy where I have the peaks in my white lights in the light booth. Now we take the proof outside the light booth. Maybe we look at it in an incandescent light, or much more typically in a fluorescent light like you probably have in your customer service area or in your press room. If I move the RGB source, that is the color temperature of the source, I essentially move where the RGB peaks are in that light source. In this example, the RGB peaks now highlight the difference between the spectral power distributions of these colors, and these two colors now no longer appear to match. Okay? The simple lesson is that color management only works in D50 lighting. That's how we make all our profiles, is to use them in D50. If we're doing special applications, we want the colors to match in fluorescent light or incandescent or tungsten or some other special lighting condition, we can use settings in a tool like Color Profiler Suite to make profiles that work in different lighting conditions, but by definition, standard profiles are going to only work in D50 light. So the short form of this lesson is to tell you that we are basically in the business of metamerism in the printing industry. We're in the business of making colors match in a certain light source, namely the light booth, where our customer signs off on them, and we then show them the final result. Remember, for lighting, the best practices are to use a D50 light booth that complies with the latest ISO 3664-2009 specification. Also, we probably want to profile and verify using M1 measurements that match those 3664-2009 compliant lamps. If you look at the end caps of your lamps and talk to your lighting booth manufacturer, you can confirm you're using compliant lamps with this ISO standard. If you're buying D50 bulbs at Costco, putting them in your press room or in your customer service area, you're probably close to D50, but it's very unlikely that you're going to be in compliance with this ISO specification. So I have one more poll question here to share with you, or the results, and this is about what kind of lights do you use for viewing proofs. And I would say that this group had exemplary results so far, with 50% of the group calibrating at least on a weekly basis, and 50% of the group making custom profiles for paper types. Absolutely excellent. I'm afraid we're all falling down a little bit in the lighting area. 50% of the respondents to the poll report they view prints in the room lighting of the shop. Only 20% of you report using a light booth. A little bit more, 24%. Okay? So one of the big takeaways from today, I know light booths are expensive and you have to find a place to put it and probably run some electrical outlet so you can plug it in and use it after you've bought the light booth. But it's really critical to doing proper color matching and showing your customer both an initial sample and a final result that match and reprints that match, is to take them into that light booth to look at those samples to prove that you're compliant. So before we close, I just want to quickly share some recommended DFE settings. These will be shown at the end of the color flowchart video that we're going to share with you in a couple of days. And I just want to highlight that the color flowchart goes through many different settings, especially when you see this other video. At the end of the day, you don't want to turn on every possible color option in the color settings on the Fiery DFE. These are the settings we recommend you use, which is basically to match your source profiles to the working spaces that you or your customers use, and to set the output profile to use media defined, the gray and black processing to text and graphics for RGB, text graphics images for CMYK, and to turn pure black on with text overprinting. You'll see more about this in the video. So we're over time already here. I'll just quickly review what we talked about today. I gave a quick reintroduction to ICC color management. We talked about the use of embedded profiles and how we select profiles on the DFE. We talked about the use of the PDFX output intent in PDFX files and how that contains a source profile we might want to use to get common appearance of PDF files. We talked about gamut compression and rendering intents, the control we call black point compensation. Then we looked at the problem of keeping black when we print and getting black and white click charges for grayscale and black jobs rather than color click charges. Finally, we talked about 3 areas of challenge with color management, which are basically the settings, the selection of the output profile, and the lighting. And finally, we quickly showed you the recommended settings for the Fiery DFE.
Great. Thank you very much, Lou. So I'm going to go quickly through some of the resources that we have available to you. And this presentation will also be made available with hyperlinks when we send a thank you email in a couple of days, along with a link to the recorded session. So the first resource is the Fiery Color Flowchart, and that you have seen throughout this whole presentation. And it will be made available to you as a PDF document with the recommended Fiery DFE color settings, along with the recorded video of Lou describing what happens when you change each setting. Be sure to check out our Fiery Color Profiler Suite website at efi.com/cps. From here, you'll be able to access our product brochure, links to watch more short videos on color, and to learn about the features included in Color Profiler Suite. You can also download additional resources as well as a copy of the free demo of the software. From here, you can also go to our resource tab, and you can download specific how-to guides and white papers, including the configuring Fiery color settings to optimize print quality, as well as demystifying color standards. We also have a FAQ here about UV lighting and how it determines which measurement mode to use. We also provide direct links to download the latest Pantone libraries, which includes a guide of how to import them on your Fiery server. And don't forget to visit our Fiery forums for color and imaging, as well as for our Color Profiler Suite to ask the experts your questions and see additional solutions.
All right. So as promised, it was a full hour of information. We are now going to take another 10 or so minutes to try to address as many questions as we can from our audience submitted both earlier during registration and now throughout the session. So let's begin with the first one.
Okay, so we have a tremendous amount of questions from the group. I'll get to as many as I can. Remember, we will answer all these questions in writing in the FAQ that will attach to the thank you email you'll receive in a few days. The first question I have here is just a specific color problem that a couple of people are reporting. This one customer says, our printer prints too red. And apparently seems that some help was brought in and this person didn't know how to use a certain computer. Generally, when we hear the comment or the complaint that the printer prints too red, there's almost always one of 2 sources for this, assuming that the printer itself has been recently serviced and that you're calibrating the Fiery using your spectrophotometer. The 2 reasons that you see an overly red or blue or green or other appearance, or several examples of this question, is number 1, that I'm not looking at my prints in a D50 light booth. You can take a print that looks perfectly neutral in D50. If you put it in fluorescent lights in your press room or your customer service area, those lights are about 8,000 or 9,000 Kelvin. Those prints can look super duper red on certain presses, okay? So that's the first thing. Get it in a light booth. I know it's an investment and you can't all go buy a light booth today. So if you can't do that, at least take it out in the parking lot and look at it in the sunlight, which is more or less like D50, and see if you still have that red appearance. If you do, then the other thing you might want to do is to make a custom output profile for your press. If you've done this, and you haven't gotten a neutral appearance, I recommend you enable the feature in Color Profiler Suite called Maximum GCR. So after we've made our calibration and profile, even if we're using the 5-step express method, we can set in the preferences to use Maximum GCR. This will always give me a gray appearance. GCR is the gray component replacement, which is a technique where we use black instead of the colored toners or inks to represent neutral areas. Chances are your colored toners or inks are more metameric, which means they're more subjective to changes in lighting. The black toner or ink is typically very neutral. If we use more of that in a profile by using this maximum GCR setting, we'll almost always get a terrific grayscale appearance. The next one I have here is a question about matching a device. This particular customer has a particular digital press that they want to match that isn't a Fiery. And the answer is, if you want to match another press, you have essentially two choices. The first one is, you can make a profile for that press and use the output profile for that press as the source profile on the Fiery. But a much better solution is to actually take that press's input profile, use the same one on the Fiery, make a custom output profile for each press, and typically we'll find a reasonable match. If we're still not matching, Color Profiler Suite Device Linker can be used to device link together profiles for different presses so that we can represent or simulate the appearance of one press on another. I have a couple questions here about G7, and I guess I'll just kind of take these together. The first one is about, if I use G7 matching, how does that impact my color management if I do a G7 calibration? And the answer is the G7 doesn't really have a direct impact on whether color management will work. If I make a custom profile and I make a custom calibration set for my Fiery, that will work with the Fiery in its default state without doing a G7 calibration. When we want to match G7 on a digital print system where we're using color management, then the best practice is to simply calibrate the Fiery, make a new calibration set using the standard settings, make a custom output profile for your paper. At that point, if you choose a source profile for CMYK that is G7 based, meaning any swap profile or a Grackle profile, and you print a test target like the P2P target you use for G7, go ahead and plot it in your curve software. You'll find you already match G7 because you're doing color management. G7 calibration is very valuable for conventional presses where we don't have color management. We can't pick profiles on your Komori or your Heidelberg to color manage colors. So we need to do a calibration like G7. On a Fiery or any digital print system, G7 is kind of nice to have. If we do it first, some people believe that maybe our output profiles will last a little longer. So maybe I'll only have to make a new output profile every 8 weeks instead of every 6 weeks as my press drifts. But the reality is it's not essential and it's not a prerequisite to matching colors. Another good question. Why is color different when I print from file versus when I import it via Command Workstation? Well, there's many aspects to this question, many possible reasons. But the two key things are that the driver settings are different when you print from file compared with the way you're configuring job properties when you drag and drop a PDF file into Command Workstation or into a hot folder. The other possibility is that you are color managing the data from the source application. So if you're printing from an application like Photoshop or Illustrator or InDesign, there's a control for the printer that says let the application manage colors or let the printer manage colors. If you absolutely have to do a file print workflow, the best practice is to set let printer manage colors and then go over on your Fiery and turn on use embedded profiles, at least for RGB, so that that printer color management can work. The best practice is to not print from the driver. Make PDF files in a standard way, submit these via hot folder or via drag and drop into Command Workstation, and you'll always get consistent output. If you're doing the file print workflow from shift to shift and operator to operator, I guarantee you different people have different favorite settings in the driver. You're going to have a very hard time achieving color consistency in your output. Next question. Why would I look at the output under D50 when I know that the customer is going to look at it in some other lighting conditions? So maybe it's better to make it look right in the destination lighting. Absolutely true. If you have Color Profiler Suite, you can make profiles that work in a variety of lighting conditions. The problem is your customers in your shop, along with hopefully hundreds and hundreds of other customers that are making you super busy, making you have to, run 3 shifts to get all the work done that's coming into your shop. You can't possibly have all their lighting conditions in your shop. So the best practice is to educate the customer that we're going to view and approve and accept prints in the D50 light booth. Anybody that's bought printing for, more than a couple of months in their life is going to immediately expect and respect that. You have a couple of special customers that say, but I want to use this, in the trade show hall that has these lightings, or in my store that has this lighting, or in my office that has this lighting. Perfectly fine to make special profiles for them. It just gets to be a little bit of a challenge since you can't view the print in your shop and see how it's going to look in that location. Okay, I see that I confused someone. Hopefully I didn't confuse too many of you here about the recommendation in Adobe applications. Do we use embedded profile or convert? Generally, if I see a profile mismatch, I'm going to first leave the embedded profile. I'm going to make the assumption that the customer or the person who sent me that file knew what they were doing. And as soon as I open it in Photoshop with that embedded profile in place, if the image looks correct, then I might choose to just move it through the workflow with its own embedded profile. But if I want to do any kind of manipulation in Photoshop or Illustrator, any kind of compositing, at that point I'm going to convert it into my working space. Okay? Once you've handled a bunch of customer files, if you know that a particular customer always sends you files that are in some maybe monitor space or particular space, and they always look right and you always convert them, then you can take the shortcut, which I often do, which is to convert right when you get the warning. Saves you some clicks.
So I want to take just one more question. And again, to our audience, we have a lot of questions, and we do apologize that we can't get to everybody, but we do promise we'll follow up with you, and we'll also compile an FAQ that will have all the questions and all the answers. We'll make that available to everyone. So just one last question, Lou, and we'll close up for today.
Okay, so this question is, what's the right rendering intent to use if I'm printing something that has both photos and vectors? For example, a company newsletter. Chances are your company newsletter doesn't have, pardon my assumption here, extremely high quality professional photographs in it, probably not shot in a very broad gamut space. Maybe they're coming off your digital cameras, sRGB or perhaps Adobe. In that case, if you have vectors that might have some logo colors and other critical colors to match, I'd recommend you use the relative colorimetric rendering. As you saw from the slides, relative colorimetric and photographic often give a very, very similar appearance for images, and they're definitely relative colorimetric has an advantage for vectors and for logos and colors where or page objects where I want to preserve the original appearance as closely as possible.
Right. So, an hour and 15 minutes of great information. Hopefully all our audience found this useful. We will follow up as we usually do within a few days with an email that will provide you a link to the recording, to a copy of the presentation, to all the resources Heather mentioned, and probably a few others, and of course the promised FAQ. We thank you for your attendance, and we look forward to seeing you in the next one in a couple of months. And to our presenters, thank you, Lou and Heather, for joining us today and sticking through another 15 or so minutes. So with that, thanks and have a great day.